All right, week 4, here's what we've got going on. We're gonna do our last transformation. So this will be a total of 4. It's called the dilation. And the first 3 that we did were the translation, the reflection, and then the rotation. And I told you guys there were gonna be a total of 4, with the last one being the only transformation that actually changes the size of the shape. So the first 3 that we did just move the shape to a different spot on the graph, but this dilation will actually change its shape, or not its shape, sorry, its size. The shape will remain the same. So if you notice, like in this first example, okay, we start off with a triangle right here without the little prime symbols next to the letter, and then it goes to this triangle with the little prime symbols. So the prime symbols that look like apostrophes, they are going to tell you which the new shape is of the 2. So this triangle started here, and now it looks like this. So it obviously got bigger, which is just one of the 2 things that a dilation can do. A dilation can also make a shape smaller. So if you think about your pupils in your eyes, okay, if you've ever gone to the eye doctor and they put those eye drops in your eyes that make your pupils bigger, and then it kind of takes a while for your eyes to get back to normal because they made them so big. That's an example of a dilation. So the doctor put those drops in to make your pupils go from a normal size to a bigger size, okay? So your pupils actually dilate on a daily basis to the light as your eyes adjust. So when you walk into a room that's well lit, your pupils are actually shrinking in size because there's so much light it doesn't want to take in too much. And when you walk into a room that doesn't have much light, your pupils are actually getting bigger. So they're dilating on a daily basis all the time. So that's what we're going to do the same thing with, but on a graph. Okay, we're obviously not going to dilate your actual eyes, but a dilation is going to either be a reduction, okay, or an enlargement. So those 2 obviously mean they're either going to get smaller or bigger in size. So we're going to have a shape, all right, and it'll either shrink or get bigger. That reduction or enlargement is going to be with respect to a fixed point. So it's going to dilate around a center of dilation. So we can't just do a dilation anywhere on a graph. You have to have a point that you dilate around. And we're just going to dilate around the center of a graph, which is 0, 0. Okay, our dilation is an example of, it's the only example that we talk about that is a non-rigid motion. Okay, because it does not preserve congruency. So preserve means to keep something the same. So if a dilation does not preserve congruency, well, to be congruent means it's the same exact size. Congruency is not preserved because the shape either gets smaller or bigger. So we call this a non-rigid. Our first 3 were rigid motions because the shape stayed the same size. It just moved to another spot. So the dilation is kind of its own thing. It's the different one of the 4 transformations that we do. Okay, a dilation produces, so the result is going to be similar figures. Now, we did a unit in class of similar triangles, and to be similar means that the shapes aren't necessarily the same size, but they're proportional. Okay, if you looked over at the example here, the original triangle and the new are the same overall shape, but one's bigger than the other. So if we were to take a ratio or make a ratio of the lengths of the sides of any pair of sides, it would be proportional. So that's what we refer to as a similar shape. Okay, now in our similar shapes, angles, so the angles that match up, all corresponding angles will be congruent. So the angles inside, those pairs will be congruent, but the sides, like I said, are proportional. Okay, so the sides will not be the same length from shape to shape. Now this is all we need to do when we're dilating a shape on a graph, is we have to use a scale factor. So the scale factor indicates how much the figure will enlarge or reduce. Now the scale factor is represented by the letter K. All right, now we're going to have a number in the place of K, but it's just represented in notes as K. All right, so K could be any number. Now when K is greater than 1, okay, maybe 1.5 or 5 or 100 or 1,000, the dilation will be an enlargement. So you can tell before you even actually dilate the shape just by looking at the scale factor whether it's going to get bigger or smaller. If the number they give you is bigger than 1, that shape will get bigger, whatever it is. Now the flip side of that is if they give you a number that's less than 1, for instance, any fraction, 1/2, 1/3. Okay, those are just common examples, but these are numbers less than 1. That means the shape is going to get smaller. Okay, so if you see a scale factor, something that says k equals 1/2, you know that new shape is going to be half the size of the original. All right, so this is going to tell you how much bigger or smaller. All you have to do, this is the one dilation rule, okay? All you have to do is take a point of the pre-image. Okay, you take that point, which has an x and a y. Okay, remember there's two numbers that make a point, and you multiply the scale factor by those numbers. So whatever point I give you, or points, in that shape, you're going to multiply each of those numbers by k. So k times x, and then k times y. All right, so if I gave you the point 1, 2, and the scale factor was 2. Well, 2 is bigger than 1, so I know that the shape would get bigger. All you would do is take that 2 and multiply it by your x and y, and that'll give you the new points of the bigger shape. So 2 times 1 is 2, 2 times 2 is 4. So this point, after it's been dilated, made twice as big, would be the point 2, 4. Okay, and you would do that with each point in the shape. All right, so I have the examples circled that I want to do, and I already did the dilation so you could see what it would look like on the graph. Now, you don't have to graph it if you feel like you understand this well enough just by doing the multiplication, but this is what it would look like on a graph. So I put the original shape, which was rectangle ABCD, right here, where the points were telling me to go. So here's what it starts as, and here's what it ends up as. Okay, I put the little prime symbols after the ABCD for the new shape. So this shape obviously got bigger, which makes sense because the scale factor is 3. So that's a number bigger than 1. So I knew just by looking at this right here that the original shape would get 3 times bigger. Okay, so all you have to do to get these new points that I already put on the graph is you take all of these numbers they give you and multiply them by 3. So if I take the point A, which is -3, 0. All right, well, -3 times 3 is -9. 0 times 3 is 0. So the new A is going to be at the point -9, 0. And that's what I put out here. Here's the original. Here's the new. Now, if we do the same thing with B, all right, 1 times 3 is 3. 2 times 3 is 6. So my new point for B, so B prime, is going to be 3, 6. Let's do the same for C. 2 times 3 and 0 times 3. That gives me 6 and 0. All right, so these are the new points that I'm writing down here. For D, I've got -2, -2. If I take these numbers, multiply them by 3, I get -6 both times. Okay, so this is a quick rule that you can use every time you dilate around the middle of the graph, which is 0. So our center of dilation was right here. Okay, that's the middle of the graph. You can just take all of your numbers and multiply it by the scale factor. Okay, so that is an example of an enlargement, which means the original shape got bigger. Okay, let's do an example of a reduction, which is going to be this shape up here. So if you notice, I, again, put both the shapes on the graph, and the original is bigger because the original is rhombus JKLM, and I did not put the little prime symbols, which means this is the first image, and then the shape that's smaller has these little prime symbols showing you that it's the new shape. So it went from this to this, so it got smaller. Now here's our scale factor. It's 1/2. The number 1/2 is less than 1. So we can tell, even if I hadn't graphed this for you guys, that you're going to have a reduction. So the new shape is going to be half the size of the original. Okay? So if we just want to use the multiplication rule and get our new points that way, you would need to multiply all of these original numbers by 1/2. Now, lots of people don't like multiplying with fractions, even though it's pretty simple to just take a whole number like 2 and multiply it by 1/2, okay? You just make your 2 into a fraction, and when you multiply fractions, you go straight across. Okay, so 2 times 1/2 would be 2/2, which is 1. All right, but if you don't want to have to worry about multiplying by 1/2, here's another trick that you could do. Multiplying by 1/2 is the same, so multiplying by 1/2 is the same thing as dividing by 2. Okay, so if you don't want to multiply by 1/2, you can divide all of your points by 2 instead. So I'm going to do that just to show you how it works, and I'm going to start with the point j. So instead of multiplying by 1/2, I'm going to do -10 divided by 2 and 2 divided by 2. So j is going to give me the point j prime, which is -5, 1. -2 divided by 2 is -5. 2 divided by 2 is 1. So here's j prime. All right, that's how I got these new points. K, we've got -2 divided by 2, which is -1. And then 8 divided by 2, which is 4. Okay, L, 6 divided by 2 and 2 divided by 2. You get 3 and 1 for L. Now the last one is M, -2 divided by 2 and -4 divided by 2. So you get -1, -2. All right, and if I hadn't graphed my new shape yet, all I'd have to do is look at the new points that I got and then put those on the graph. Okay, so that was an example of a reduction, meaning the original shape shrunk in size to the new shape. Okay, it shrunk by half its original size. Okay, now the last type of problem I want to show you with dilations is, just like we've done with the other 3 transformations, is if it's already been dilated, the new shape's on there, the original shape is on there, and you are asked to tell me to identify the scale factor. What was the scale factor that was used in the graph in front of you? Okay, all you have to do is pick one pair of points. Okay, D and D prime, E and E prime, or F and F prime. Okay, I'm going to pick D and D prime, and I want you to just write them down. Okay, look at the graph. Where is the point D? Well, that's at 0, 6. Okay, well now where's D prime? D prime is at the point 0, 2. Okay, I just want you to pick one pair. When you have that pair of points, all right, I can't do anything with zeros, so I'm going to look at these numbers here. All I want you to do is make a fraction with either your x's or your y's. Okay, but you want to put the new point, in this case D prime, over the original. So I'm going to put the 2 over the 6. Okay, so what do I get when I have 2 over 6? Well, 2 over 6 simplifies to 1 over 3. And that's actually the answer you're looking for. That's the scale factor. Okay, 1/3. So that's what you were asked to do in these last 2 problems. Just make a fraction with either the x's or the y's with one pair of points. Okay, D, E, or F. So let's double check to make sure 1/3 makes sense. All right, 1/3 as a scale factor means that the shape will shrink in size. So if we started with this triangle, okay, no prime symbols, and we ended with this triangle, it has the prime symbols, does that look like it shrunk? And it definitely does. All right, this new shape is approximately 1/3 the size of the original. Okay, so let's do the last one, and then I will stop the video and post your homework problems too. All right, so let's see what the scale factor is. All right, I'm going to pick W's again. I've already done this once and then erased them, but I'm going to pick W and W prime. Okay, and then W prime. What are these points? Okay, well, W is at -2, +3. Oh, actually it's at 2, 2. W's right here, 1, 2, 1, 2. Sorry about that. -2, +2. All right, where's W prime? W prime is way out here. So if we go left 8 and up 8, that'll give us the location of W prime, and that's how we write it. So if we do the same thing that we did over here and either pick the x's or the y's and make a fraction, we'll get our scale factor. Okay, I'm going to take the y's because they're positive. And remember, you put the new point, the new shape, over the original. So if I put the 8 over the 2, or even if I did the same thing with the x's, -8 over -2, these fractions simplify to the number 4. Okay, 8 over 2 or -8 over -2. So if we looked at the picture that was already dilated, does 4 make sense? Well, if we started with this shape, it has no prime symbols, and we ended with this shape, it's clearly a bigger shape. All right, it started here and it ended here. So our scale factor makes sense because any number bigger than 1 means an enlargement. The shape will get bigger. This one grew 4 times its original size to get the new shape. Okay, so if you're asked to give the scale factor, just pick a matching pair of points, all right, a matching pair of letters, and make a fraction either with your x's or your y's. You should get the same scale factor whether you use x's or y's. Okay, so that's it for dilations. Just remember to use multiplication. Okay, if you have to dilate a shape, just take your x and your y and multiply it by whatever scale factor they give you. And remember just to send me your notes and your homework assignment because I give you guys credit for both. And then if you have questions during the week, please reach out, or you can ask me on Friday during our Google Hangout.